Okay, so the first thing you're going to need in order to use SimVim Cockpit on your X-Plane installation and to start building your home cockpit, of course, is an Arduino. The website says that you need to use an Arduino 2560 Mega. I have two of them right now. This one is actually made by Arduino itself, the company Arduino, I guess. And my other one is made by Velamin. That's the one I'm actually using in my setup right now. So the only thing you really need in order to connect it to your computer and install the firmware on it to start, wiring it up and using it is a USB connection, a USB cable. So that's the way you're going to connect it to the computer to basically flash the firmware onto it. I highly recommend that you get a power adapter, also that you can supply power to the Arduino. The reason is if you plan to hook up a lot of devices, a lot of displays, 7-segment displays or LCD displays, each one of those is going to drain a little bit of power. And the Arduino 5 volt and 3.3 volt pins can only give so much, so many milliamps, per pin. And if you use a lot of it, you're basically going to possibly be starving the Arduino of power. So it is highly recommended that you use a power adapter so that it can have more juice basically to spread out. The Arduino could take anywhere from 7 to 12 volt power adapters, and I believe I've seen words mentioned that maybe 800 milliamps, but anything you can use, that's 1 amp or even more will be better. That way, if any of the devices demand more, it'll be able to feed them. What I did with mine, you've probably seen it in some of my other videos, I actually used another power adapter. It's actually a 12 volt power adapter, but I didn't hook that one up to the Arduino. I'm just using that one to feed the voltage to my lights that are 12 volts. And I talked about that on my video about using relays, because the 3 lights that I've been using with it is actually 12 volt lights. So if I try to hook them up to the 5 volts of the Arduino, the lights would be very dim, so that wouldn't work out. Okay, so obviously in order to do your wiring in your cockpit, you're gonna need wire. That's a given. And then you're gonna be, whatever you decide you're building, you're gonna obviously need components. For example, lights. This is a dual rotary encoder. There's also single ones that are much cheaper. This is a multi-position rotary switch, and then a regular toggle switch. I have a potentiometer, and then a slide potentiometer, and then different buttons here, push button, momentary contact, and then I have a button that also has a light. Actually, that's just a light, sorry about that. And this is a push button that is latching that also has a light built into it. So depending on what your goals are for whatever you're building, you're gonna need a bunch of different components. And of course there's many more than this that you can use. I just grabbed a handful of the ones that I have laying around here that I still haven't used in one way or another. So that's just to give you some ideas. When we do the wiring, I'll hook up a couple of different things, and you can see how they get wired up. Okay, so I got myself a little bit of wiring here with different types of components, just so you can see how each one of them is wired. We'll start with a simple one, the toggle switch here. This is a 2-position on, off, on switch. So it has 2 leads that are going to go to input pins on the Arduino. So you can choose 2 different functions for when you flip it to one side or you flip it to the other one, and in the middle it would be off on both positions. And the way SimVim Cockpit does it, it behaves a little bit differently. So rather than being on with the 2 on positions and off with a middle one. Sometimes depending on the switch that it is, it'll have a function for the off position and it'll be off for the on position. It's kind of hard to explain it, but maybe when we're doing it inside the cockpit you'll get to see how that works. So basically you're going to have the common, which is the ground, to the middle, and you're going to take that either to the Arduino, to one of the ground pins, or you can do what I've done, because the Arduino only has a couple of ground pins. So if you start hooking up a bunch of switches, you're going to run out of ground really quick. So what I've done is I've made the ground and power distribution blocks. So basically I take the 5 volts and send it over to one of the rails here, and I take a ground, a common, and send it to the other rail here too. And that way when I need to tap off of it, I got a lot of them to choose from instead of just a few that are on the Arduino itself. So the common will be going from the switch, and I took it directly over here all the way to this one here, and then the 2, which would we call positives, are going to go to the inputs on the Arduino. In this case I use number 2 and number 3. So when we start messing with the configurator, those are the inputs that you're going to select for this switch to assign whatever you want to assign to it. Okay, now for the light, this is just a light here. So obviously the light is an output, so we still need to get a positive from the Arduino, which in this case is going to be an output, it's not going to be an input. But all of the pins, you can select how you want to assign them, whether they're an output or an input. And any LED lights you can get directly off of a pin that you assign as an output. So basically anywhere from 0 all the way to 12, and then all the way from 22 all the way down here to 53, you can assign as outputs or inputs. The analog ones you can only use for analog devices, although there are also the instructions on the website that talk about using boards in order to be able to hook up a lot of them, a lot of those types of devices. So everything that you can do with Arduino, you can multiply it by using external boards, and I'll be talking about some of those, the multiplexers, a little bit later on. Okay, now for the potentiometer obviously, like I said earlier, is an analog device, because that one is going to be a range. When you turn it, it's going to be either all the way off or all the way on or somewhere in the middle. So that one, the way you wire those is you take the positive rail, the 5 volts, and you're going to send it to one of the outer pins, and you're going to get the ground, the common, and you're going to go to the ground rail. In the middle one, which is called the wiper, that's the one that is going to have the variable voltage depending on how you turn the potentiometer. That one is going to go to the analog input on the Arduino. In this case I put it on A15. So when we want to select something for that particular potentiometer, we would choose input A15 to assign it whatever we want. Okay, next we're going to talk about Rotary Encoders. It is one of my favorite components and probably one of the most useful. Although, like I said before, it depends what you're doing in your setup. But these right here, you can use them for example, the altitude, changing the altitude on the autopilot, the heading. You can change the speed. You can use them to tune the radios. And that is specifically what the dual rotary encoders like this one here, what they're very good at, because they have the middle one and they have the outer one, which could be for the big digits, like if you want to go 118, 119, 120, and the little one here in the middle, you can do like the point 35, 40, 45, all the decimal digits. And it has a push button in the middle too. So when you push the center here, it's like a switch, so you can actually use that, like for example, to switch the main and the standby frequencies or any other thing you want to assign it. These are pretty expensive. I think that I got 4 of them for about $54 or somewhere around there. They're pretty expensive. They're up to $20 each sometimes, but I bought a 4-pack and they became a little cheaper. These right here, I think you can get like a 5-pack. You can get it for maybe $12 or $13. They recommend that you don't use these that have the little board. Vlad told me one time that he thinks that, or he knows that they can cause problems. I'm not gonna say I haven't had any problems. There has been times when something has been acting a little bit weird when I try to use my encoders. Like for example, they'll just go in one direction but not the other, and then 20 days or 30 out of the month they'll be working fine, but one day they'll just be acting weird. I don't know if that's something to do with the encoder itself or if it's something to do with my wiring. But these right here, the bad thing about them is that they need separate power. So in this case, I got the yellow one and the orange one, which are the positive and the negative. They go to my power rail over here, and the blue one, the purple one, and the gray one are the signals for the rotary encoder and the push button in the middle, because it also has a push button in the middle. So I set them, once again, I set pin 2, 3, and 4. So pins 2 and 3 will be to assign it to whatever function you want for the rotary encoder, and pin 4 would be for the push button in the middle. But that's the bad thing about it. They need the extra 2 wires for power. I believe if you get the other encoders that are much cheaper and they don't have the little board, you don't need to provide them with separate power. They just basically will get the common, and they'll get the 2 signal wires that are basically going to be the inputs. But I don't believe those come with a push button. That's the only negative about it. So another thing that the dual concentric rotary encoders are good for is, for example, for the GPS panels, the G1000, the GNS 430 and 530, and probably all the other ones that use dual rotary encoders. They're very useful for that. Like I said, they are expensive, but they are definitely useful, and especially if you want to build something that mimics the real aircraft that have the dual rotary encoders there. You don't have to have 2 separate ones like you do with this one. You can all do it together with one of those. Okay, now we're going to get a little bit more complicated. We're going to start talking about using the multiplexers, which are these right here, so that you can increase dramatically the number of inputs you can have into your Arduino. Actually, they can be used as both inputs and outputs, but if you read the website, the SimVim.com website, you can see all the wiring information very, very clearly laid out on there. So basically, pins number 22 through 28 are the ones that are used for the bus and for the different timing signals and data signals for LED displays or LCD displays, 7-segment displays, and anything else that you can hook up to this thing. And those are the ones that are way down here on the bottom. Okay, so if you take a look at this little chart that I made, you can see that 22 is S0, 23 is S1, 24 is S2, and 25 is S3. 26 is the signal line, 27 is the L, I forgot what he called it, 27 is D, and 28 is T. For the inputs, all you use is S0 through S3. So that would be, my wires would be the orange, white, yellow, and green, which is what I have pretty much done right here. I hooked up all 8 of them here because if I wanted to do any input boards, output boards, then I already have everything laid out. And what I would do is I would use some of these to basically make distribution blocks. And some of my other videos, you can see when I used one of these, and I also did one of these, and basically that just gives me a bunch of pinouts, you know, to branch out and put a whole bunch of boards. What I had to do with this one is just basically solder it so that it can be basically all linked together. And what I would need to do on this side is that in the 2 middle pins, I would need to put a jumper wire on each one, because as you can see in the back, they're not linked together. But that's just to multiply the number of available pinouts that I can use for the data bus. For the multiplexers, what you need to do is you need to bring it power and common to the 2 bottom. They have the writing on the board, so it'll say GND for ground and VCC for the voltage. And the 3rd pin, which I don't have anything in it right now, you would need to actually put another ground wire on that one. So what I normally do is on the bottom of the board, I just solder a jumper from this ground over to the 3rd. So the 1st pin to the 3rd pin would be jumpered. And then next are the S0, S1, S2, and S3 wires, which come from the Arduino. And you need to make sure you have them in the correct order, because if you don't, you're gonna have issues and they're not gonna work properly. Your commands and everything are not gonna work. And the last wire, which is the Z, that's gonna be the signal wire that goes to the Arduino. So you know how previously whatever you connected to the Arduino to the input pin that you wanted to assign, this time you're going to put this wire to the Arduino pin. And basically what that does is it multiplies 1 pin on the Arduino to 16 inputs on this multiplexer board. So for every 1 pin that you send out a signal wire to, you'll have 16 inputs where you can put all kinds of switches and buttons and everything. Now in this case, I'm still working with the encoder here, the Rotary Encoder. So same thing as before, you still have to provide it negative and ground power, which I'm getting from my little rail over here. And then the 2 clock wire, the clock and the data signal wires are going to go to the pins on the multiplexer board. And then the 3rd one, the blue one, is the one for the push button switch that's in the middle, and that goes to another one. The 2 first ones that are for the encoder, they have to be next to each other. They cannot be separated by anything in between. They have to be consecutive. And if you get them wrong, because sometimes you'll turn the encoder and your numbers or whatever you're trying to change in the simulator will actually be going in reverse, all you have to do is flip those 2 wires, either here on the multiplexer board or over here on the encoder. But once you flip it, it should go up when you go up on the encoder and go down when you go down. And you can do the same thing for the output 16 channel multiplexer boards. The wiring is a little bit different than it is for the inputs, but it's going to use the same 8 bus wires. It's going to use 5 of them, including the blue one. I believe that I have here, the blue one would be the signal wire here. Since it's going to outputs, it's obviously it needs to send out a signal to send the command to whatever pin you want to send it to. Alright, so that's it for this part of it.